because we don't have a corrosion issue. But when you look at the cathodic protection, there are a lot of steps along the way because that requires an operational maintenance. And also we included that you need to go out and repair certain areas. There might be areas in how it was installed and so on. If we look at the time of construction, it would be cheaper to install cathodic protection. But when you look at the end of service life based on 0% net interest rate, the optimum solution would be stainless steel in this case. Based only on economy. If we look at 2.2 interest rate, you can see the curve flattens out. And that's a break-even point for what is the cost optimum, at least for the high-grade stainless steel. And if we go as high as 7%, the cost optimum solution, if you use 7%, is actually cathodic protection in this case.
So that's passive cathodic protection?
That is passive cathodic protection or prevention. You can say the strategy where it's used after 75 years is still assuming that you apply it before corrosion have actually caused any damage. So it's still a passive system. So the interest rate has a huge impact on what the optimum solution would be in this case. So that's a discussion with the client that they need to set forward what the relevant interest rate should be. Of course, the owner can then decide based on not only the life cycle costs, but also what risks, quantified risk, economical risk and uncertainties. This also means that you can, when you're pricing these things, you can see what has the highest impact on my price, where's the largest uncertainty, and you can dig further into that and try to limit those uncertainties based on this. Of course, the appearance, there are some differences in appearances. Robustness, I mean, if you reduce the amount of steel in the structure, the robustness will be different. And sustainability is now also becoming an issue to a larger extent. Successive calculations, in our view, you get a higher precision in your cost estimates, and instead of just pricing an actual average cost, you can also have uncertainties taken into account. Another example, you can still see what is the cost optimum solution, but if you have very large differences in construction costs, that also, I mean, taking money out of your pocket has an importance to a lot of owners. We have to realize that. On life cycle assessment, COBE is dealing with a lot of different issues in relation to life cycle assessment and sustainability. One of them is sustainable structures. And basically what life cycle assessment is an assessment and evaluation of the potential environmental impacts, including resource consumption and emissions which are attached to the life cycle of a product or service. And the product in our case could be bridges, tunnels, marine structures or whatever. It includes all the phases throughout the service life, just as we had with the life cycle costing. Basically, it's a tool for optimization, which is the same as the life cycle costing, and it would lead to getting the right basis for what is best from an environmental point of view. Again, it's all phases throughout your life cycle, from production to disposal, taking down the structures and including them in, for instance, roadworks. I think we are exceeding 90% of the concrete is being reused in Denmark. I don't know the percentage for the US, but they go into roadworks. So that's important in a life cycle perspective. When we look at different activities, you both have the incineration processes when producing components, but also the disposal. There are a lot of different things that are emitted to air and different environmental impacts. Very often, global warming, we look at that as an issue, and I know as an engineer and my colleagues as engineers, this global warming issue, it creates a lot of skepticism between many of our engineers, because they say, yeah, okay, 2 degrees Celsius increase, is that scientifically valid, and This is very difficult to prove statistically based on what they have, the historical data on that. But then again, it in my view, it's not an excuse for not doing something good for the environment, not limit the amount of energy used and limit the amount of pollution to the air and so on. But that's two different aspects. So we're not trying to get into politics when talking about global warming. It could be as simple as a basic Excel sheet, carbon footprinting, all the aspects within the structure. And this one for a sewage company, you need to look at all different aspects. It's not only the carbon dioxide and global warming. In this case, you can see it's a very low person equivalent compared to persistent toxicity. So you have to remember to look at all different aspects. Life cycle costings and considerations on sustainability, you can look at all the different phases in a project. And that is a little to be decided. When should these issues be included? Should that be in the pre-design phase, in tender evaluations, or during construction? That you can also price some of these aspects with different sustainability solution and finding an optimum. And you would have to try and do that to many cases. You have to comply with all national and municipality goals and legislations. We have 10 years back we participated in an innovation project called Green Concrete. Green is of course not only the color, and the outcome of the project was that we in Kowi we designed a bridge which was called a green concrete bridge because the concrete that went into it was designed as to limit the CO2 emission, basically. This bridge is being extended. We did the design of that last year and looking also at possible reductions in carbon dioxide in the mix composition. You can get far just by replacing the cement type from a high sulfate resistant cement to a medium or moderate sulfate resistant cement. Also when including fly ash, and now we are still within our codes and norms, that's a very high number if you have many cubic meters of concrete. If you go to slag cement, that would bring you even further in reduction. However, we cannot all just go and use slag cement because we'll soon run out of slags in the world. So that's another option. It's not just saying, okay, we'll just use slags all over. So that's another thing. All the possible reductions are found based on inventory analysis, based on the same LCA methodology. That's important. You can look at databases, and there are databases in the US, databases in Europe, where you have input parameters on these things. But they're average values. You have to address local values. For instance, on steel, when they produce steel in Sweden, they have a lot of water energy for the production, so the CO2 emission is very close to zero. If you go to China, it's a different process. So there it has a high impact. So you need to get your data from the area you're working in. Just looking at, very often we are still operating down here with life cycle assessment, with carbon footprinting. So this is an arbitrary example on how it could be in future, setting up different strategies and look at environmental impacts at the end of service life. You could still also think you could use interest rates in relation to this. That could reflect that they are very good at developing new methods and new industry in China, for instance. It could be a lot of things. In the Copenhagen Metro, Cityring, the extension of the Copenhagen Metro, that was actually the first time where there's been a specified limit to the CO2 emission from concrete. It gave some grey hairs to especially the cement producer in Denmark, And you have to know exactly where to place things, because you don't want to take a lot of persons out of the industry, and you don't want to make it unrealistic. Also volcanoes. I would believe that you know about the Eyjafjallajökull in Iceland that erupted earlier this year. We have a colleague who is very dedicated to volcanic activity, and she immediately went to another colleague we have from Iceland and said, "Can you have your parents go and dig some dust for me, so we'll look if it can be used as substitute in concrete." And she's been looking in a microscope in this, and she's made different strength measurements and so on. It showed actually that the Icelandic volcanic ash may not be that efficient because the strength development was not that high. But there are many volcanoes in the world where they have good cementitious properties and where you can use them for a cementitious substitution. We participate in FIP, the International Committee for Concrete Structures. They have a commission in particular on interaction between the environment and concrete structures. So that goes a lot with sustainable developments. We are involved in Commission 3. I'm participating in Commission 3. Carola is participating in Commission 5. And what we are presenting here is actually how we can combine these in a future methodology. So we are working on life cycle assessment. The task groups that we're looking into are the different ones. And FIP just started a new working group across the commissions, because they say sustainability is so high on the international agenda that it has to be overlying all the commissions that are there. We are part of a project called ETSI. It's a bridge life cycle optimization, where the ambition is to look at these things. It's a project that was started in 2004 with participation of the Swedish, Nordic, Finnish road directors and some universities. And they've developed some of the tools. We went to talk with the Danish road directors, said, we think that we need to look into some of these aspects. And they looked at this and said, this might be the place to work on. And they invited COWI in on the same project. So it's now all the Nordic authorities are included in this project. There's been an LCC tool developed in Sweden. The life cycle assessment tool has been developed in Norway. Also, there's the Finns have made on life cycle culture, aesthetics, and so on, which is much more difficult to characterize. And also, they work on a common database for the Nordic road authorities. And what we do in COWI is we test these tools, and we help providing input on methodology on how to use this. The Swedish Road Authority, they already include life cycle assessments as part of their evaluation in tender projects. The rest of the road authorities, that would follow. I mean, that will follow from these methodologies that we develop in this project. So it's a question of time. If you want to be out there and being at the edge of things, you need to address these aspects also.